As many of you guys know who are longtime listeners, this is my house, and this is the bubble wrap addition I made to it. But I also made a shed, a wood shed, specifically a Shusugiban wood shed. And so you can see on top it has a fort. That's right there for my kids. When I started designing it, my kids were young enough to enjoy the fort, and then by the time it was done, they really never have used it. It's actually my biggest regret of the project is putting the fort on top because it never gets used. However, I was interested in exploring this kind of Japanese tradition of burning the wood, and when you burn the wood, it gives it a protection from rot and insects and moisture, and interestingly fire, which, you know, if you don't see the kind of meta coincidence in that, or irony in that, burning the wood protects it from fire. And we were looking at buying the wood already with the Shusugiban, already with the burnt texture, but it was like $17,000. And so I kind of had a discussion with the contractor, and I said, look, let's go ahead and burn it ourselves. And he said, I don't know how to do that. And I said, well, let's figure it out. And he said, I really, don't know. I said, listen, I will sign something indemnifying you if there's a problem, but it's a shed. And even if we have to do it twice, it's going to cost us way less in wood and labor than it would in materials and shipping. So, here's the shed, here's the fort on top of it that you can stand on. And so we used a roofing torch and we burned it just like this. And it was a pretty interesting little process. It actually went pretty much as you would guess. And we wound up with the shed, and the shed has this little kind of, I don't know if you could tell, it has this little elbow angle door here. I took a picture of it yesterday. Yeah, you can see, at first we built that out of wood, but then we had to build it out of steel because it turns out you can't do that angle without it sagging considerably out of wood. And then here's the shelving in the back of the shed, but the shelving also serves as a ladder, and then there's kind of a trap door that leads up to the underused fort. So our assignment today was to put these flooring options in order from most embodied energy to least embodied energy. And I put it more or less in alphabetical order: carpet, linoleum, rammed earth floor, stone tile, terrazzo tile, wood, vinyl composite tile or VCT, and commercial vinyl flooring. And if we look at the embodied energy in millijoules per kilogram, we wind up with carpet being the most and vinyl floor being second. Vinyl composite tile actually has less than you would think. Linoleum is far down, then wood, then terrazzo tile, then stone, and then rammed earth floor. So what are the takeaways of this graph? Well, the first is that anything that has polymers in it, anything that has plastics in it, anything that is synthetic is likely to have a lot of petroleum in it, and petroleum products have a lot of embodied energy. And by embodied energy, we're talking about all the energy that it takes to harvest something or mine it and process it or manufacture it and ship it, everything kind of upstream of the building. It does not include benefits to the building. So it doesn't include like the energy saved because it's insulation, or the energy, the power created because we're making a photovoltaic. For that, we need to do life cycle assessment. That accounts for the entire kind of cradle to grave or cradle to cradle arc of a building material or a product. And don't confuse life cycle assessment with life cycle cost analysis. That's how we're looking at accounting, like how much does one particular boiler cost relative to another boiler, not just in the installation first costs, but also in the long-term operational costs of one boiler possibly being more efficient than the other. All right, now. What are the other takeaways? So the first takeaway is that anything with petroleum products like carpet and vinyl flooring have a lot of embodied energy. And we obviously want things that have less embodied energy, at least in a per kilogram. This is all per kilogram. We'll talk about that in a little bit. Second, vinyl composite tiles uses a bit less than you would think. Linoleum seems like it should be a product that involves a lot of polymers and plastics and synthetic materials, but actually linoleum is an organic material. It's linseed oil and jute and sawdust. It just looks like it's plastic, but it was kind of the old school plastic before we had plastic. Wood is an organic material. They generally have lower embodied energy, as do kind of older materials in general. So we have terrazzo and stone, and of course rammed earth is like a 0.5 millijoule per kilogram. Now, a couple things with the stone and the terrazzo, that's all per kilogram. It's all per kilogram, and those are heavy things. So if you're not sure what vinyl flooring is, and most of you are, I know, but vinyl flooring is that kind of institutional hospital flooring that's easy to clean. This is kind of how we usually picture it. Lately, they've started making it where it looks like stone or wood or ceramic tile. And it kind of does in photos, but it never really does when you're there. Vinyl composite tile, VCT, is this stuff that you see, most associated with like your elementary school. But even that these days doesn't always look like an elementary school. So we have versions that look a bit more like maybe stone or terrazzo. All right, so let's look at our list again, and let's say that we chose rammed earth. Well, rammed earth may be not practical for your particular building. Rammed earth is not known for working on the 4th floor of your office tower because there's just not enough. Well, you know why. And it also is not known for handling high commercial traffic. So let's assume, or even moderate traffic. It's really just for kind of really light traffic. So let's assume that rammed earth may be out. And so then you'd say, okay, let's do stone. Well, all right, let's do stone. There's a couple problems with just looking at that graph and saying, let's do stone, because that stone number is an average, but actually if we zoom in, granite is quite a bit more than shale, and granite's actually more than everything. So it kind of depends on which type of stone you get. And this is going to be a recurring theme, is that to get the embodied energy right, you're going to have to do a lot of research into the specifics. And that has a couple of really significant impacts on your design. Number one, it's not enough just to kind of look on a chart and do some Google research and just declare victory, because a lot of it depends on a whole bunch of other factors that we're going to get into. Even if it looks better, it may not be. And secondly, you only have so much design time. You only have so much design time. And so I personally would prefer you to focus on energy use, low E windows or variable refrigerant flow HVAC systems, or some of these things. To most of the people who look at this and actually run the numbers, those are things that are more important to the environmental footprint of a building. And I think finally, I've been kind of hounding them about this. I don't know if it's had any impact, but I think finally maybe NCARB's starting to get the message. I think it was a situation where, 15 years ago or 10 years ago, NCARB said, we need to start testing on sustainability. And like so many architects, they kind of believe that sustainability was pretty much about materials and products. And actually sustainability is much more about energy use, and energy use is much more about the use of the building in terms of good insulation, air tightness, and that kind of thing, than it is about products that have a low embodied energy or low water use, and the whole thing is always kind of ridiculous. It's like watching one of those car commercials, right? So in a car commercial or a truck commercial, they'll tell you that this particular truck has the most legroom in the back seat or the most torque or the best fuel economy or the most power or the longest cruising range or whatever. There's always something, right? And given that there's only a couple of, maybe 5 cars or trucks in a given class, and given that there's, I don't know, maybe 50 different dimensions that you could measure a truck or a car on, it really is kind of silly to say it has the best anything in its class. because you know, everything, you know, it either has, if it doesn't have the most power, it probably has the best fuel efficiency. These are trade-offs that designers make between power and fuel efficiency. Well, in the same way, the manufacturers of products have been greenwashing us because they'll say it's recyclable. Well, yeah, but so maybe it has a lot of embodied energy because it's made from plastic, or they'll say it's recyclable, but maybe it's technically recyclable and theoretically, but it doesn't mean it ever gets recycled from a job site. Or maybe they'll say it uses very little water, so it's sustainable. Or maybe they say it's sourced locally, which is, you know, all these are sustainable, or low off-gassing, or low embodied energy, or they save energy in its operation, so forth. And so it's very difficult to kind of parse all that. So I think that manufacturers have done a pretty good job of using some of this stuff to greenwash. And I think, frankly, that NCARB took the bait and started talking about this stuff in the tests. It's not important. It's just not as important as the other stuff. But it's on the test, so we're going to cover it. All right. So granite, limestone, marble, sandstone, shale. All right. That's where we left off. Now, the other issue, of course, is that this is an embodied energy per kilogram. And stone is about 10 times about 10 times heavier. I'm sorry, about 5 times heavier than wood. So if we're debating between stone and wood, we could start off by saying, you know, by looking at this graph and say, oh, stone here is way less than wood here. It's about about 1/5 as much, but it's also about 5 times heavier per square foot of installed stone tile flooring versus installed wood flooring. And so then you say, okay, well, actually then one of them is 5 times more per unit weight, but the other one is 5 times as much weight. So they actually, per square foot, which is really what we're dealing with on the floors, we're dealing with a certain amount of embodied energy in millijoules. And if one is heavier and the other one is lower embodied energy per unit weight, and they kind of wash out. So really, stone and wood look like they're very different, but they're actually pretty similar. And so we say, okay, well, maybe it's stone. And then stone, we realize, well, you know, is it granite or is it shale? And then beyond that, stone is heavy, and stone needs to be shipped from somewhere. And so is your stone going to be quarried locally, or is it quarried quite a distance away, maybe in India, and shipped over? I went to get stone for my countertops, and they were shocked. I just wanted it was at the quarry, and they kept trying to sell me stuff from all over the world. And they were bragging on it. You know, they're like, this stone is from Nepal, and this stone is from Sri Lanka. I don't know. A lot of it was South Asia, but and they were so excited about that. And I said, no, I'll just take the one variety that you have quarried here in northern North Carolina, which is about 45 minutes from where I live. You know, right over there in that hole, I'll take the stone from that hole. And they thought I was nuts. And the installers came out and they were so excited. They said, no one ever buys this stuff anymore. So it's a situation where the quarry was set up to sell stone, and then they started importing stone, and everyone buys the imported variety. There's probably 100 different varieties or 50 different varieties at this quarry, but only one of them is quarried there, of course. And they were so excited. They were like, this looks so good. Why does nobody get the local stuff? So anyhow, then you say, okay, well, maybe we should do wood, because the stone is, you know, there's no quarries nearby and it's being shipped a long way. And that's a lot of other embodied energy that's not going to be accounted for on this graph. This stone graph just assumes that all the stone is quarried at an equal distance. But if you went to wood, well, there's another issue, which is wood has to be sealed. It has to be treated, although maybe your stone does too. There might be chemicals that you put on your stone tile flooring, but and we see that epoxies and resins are notorious. All these finishes are notoriously high in embodied energy. So epoxies, resins, lacquers, paints, even waxes, which you think of as organic, but maybe they don't have that much organic material anymore. Wood stains, varnishes, these all have a significant amount of embodied energy. And oh, by the way, almost all of these also off gas. So things like carpet and vinyl flooring and epoxies, all these synthetic materials, not only do they Now there's another dimension to kind of brag on your best in class or worst in class. So a lot of these petroleum-based products, plastics-based products, polymer-based products, non-organic products, they tend to off-gas. And off-gassing, of course, is the contamination of indoor air quality by the kind of gradual deterioration of often synthetic materials. And sometimes the off-gassing stinks. You smelled that before, but often it off-gasses and it doesn't smell. Sometimes it smells good because like that new car smell is actually the chemicals on the upholstery in your car off-gassing. So sometimes off-gassing smells pretty good, even if it's almost uniformly not thought to be healthy. So then we would have to say, okay, now there's all this embodied energy from epoxies, resins, paints, waxes, wood stains, and varnishes, and so forth. And then we'd have to say, well, but how much, this is per kilogram, so how many kilograms really are we going to use on this floor? Anyhow, as you might imagine, it's a not very complex, but a quite complicated spreadsheet that you're going to have to create to really determine the embodied energy. And then even for my woodshed, I was pretty excited at the Shusugi Ban because, you know, it's a low off-gassing. I guess there's the embodied energy of the roofing torch, but it's pretty minimal. So it's a low embodied energy finish. But in the end, when we did it, it made it so even if you brushed against it barely, you were just completely covered in black soot. So we had to seal it in the end anyway. So we put a wood finish on it anyway to prevent the charring from rubbing off on your coat or sweater or whatever you went to get your bike. So we wound up putting the nasty stuff on. Now, what are you supposed to do if you have wood or have a finish? Well, you have, I guess, two choices. One is you could specify materials that don't need a finish, or you could specify a low finish option in a material. So maybe it's, you know, masonry that doesn't get painted, or it's CMU that doesn't get sealed, or maybe there's just, you know, no sealing finish at all. There's no drop sealing, everything's exposed, whatever. Or we can use finishes that are low embodied energy, and so that includes like Shusugi Ban or sandblasting. We can sandblast metal and bring it back to life. It takes out some of the rust and other byproducts of oxidation. We can sandblast stone and get some mottled texture on that. And so maybe it's sandblasting, maybe it's more natural material that can be put on a more natural finish that can be put on. So we either can do a low embodied energy finish or a low finish strategy altogether. So even my low embodied energy finish wound up being a relatively high embodied energy because now we burned it and we sealed it afterward. But at least my shirt right now is not covered in soot because I bike to work every day. So then we can say, okay, you know, people are always kind of debating whether concrete or steel is better, because I think architects and lay people have a fixation on the superstructure of a building, maybe often ignoring foundation, roofs, systems, and finishes, but that's probably a question for another day. So we say, okay, let's look at the embodied energy of steel versus concrete. Well, you know, within steel, we have virgin steel, which is really high embodied energy. And then we have 100% recycled steel, and that's much lower, but still much more than concrete. And then we have kind of the steel in the middle, which is steel with a typical amount of recycled content. So steel is one of the more recycled. This is another one of those bragging points in the greenwashing of manufacturer literature. Steel is very highly recycled. But even recycled steel takes if you've ever been to a recycled steel plant, you can just see the energy. There's one down the street here. Well, it's about a half an hour away, and I take the students every year, and we go in, and man, their utility bill is $1 million a month, and our utilities here in my part of coal producing Virginia are about half of what they are average nationally and about a quarter of what they are in California. So there's a significant amount of energy that even goes into recycled steel because that's a recycled steel plant. But there is a lot of recycling of steel, and it is still a lower embodied energy option. But you see it's much more than concrete. Now, steel is heavier than concrete on a per unit volume basis. So, but concrete, man, we have to use so much more concrete. So if you think about the volume of concrete in a concrete structure relative to the volume of steel in a steel structure, you start to realize that this is a bit misleading if we're looking at it per kilogram, because in one case we just have way more kilograms of concrete, not to mention the not insignificant amount of steel rebar that's in the concrete too, that still has all of this embodied energy. So so it gets a little confusing pretty quickly when we're trying to compare something like concrete and steel. But wait, there's more. Concrete, it turns out, from a climate point of view, the embodied energy is a rounding error. The embodied energy is significant. They have to, heat up. I think they heat it up to like 3,000 degrees for several days to make the concrete or the lime or whatever it is they make the concrete. But in reality, what happens is the process of making concrete itself is itself independent of the climate impact of the embodied energy in concrete. When we make cement, it directly produces carbon dioxide. So what happens is like something called calcium carbonate thermally decomposes, and it leaves behind the lime and the carbon dioxide. And the carbon dioxide from the concrete production, just as a byproduct, not from the energy to make the concrete, but from the concrete production, is significant. 1/12 of all the carbon we put in the atmosphere is from the production of concrete. 1/12 is from the production of concrete. If concrete were a country, concrete would be the third largest producer of greenhouse gases. It would go China, #1, US #2, concrete #3, and then the other countries below that. So concrete, even though it has seemingly a low embodied energy, it's actually just a crazy climate culprit. But you would never know that if you did a Google search. So if you do a Google search for embodied energy, this is what comes up, I think, second. And you see that it looks like concrete has very low embodied energy, because it does on a per weight basis. But on a decision making for your building basis and looking at the equivalent kind of impact on the climate, concrete is really, really wicked. All right. If we're talking about windows, let's take a look at that. Aluminum framed, you see, is quite high. Aluminum has to be mined and processed, and aluminum is super abundant on the earth, but in tiny amounts everywhere. So aluminum mines are these giant pits that require a lot of energy to remove all the soil and sort it all for the aluminum. PVC is a plastic, and so it has oil in it. Wood is an organic product, so it's lower. So we see that things that are mined. So let's go through the takeaways. That's what we're going to do for the rest of this session. What are the takeaways? Well, the takeaways are things that are mined or processed have high embodied energy. Things that are plastic or petroleum products have high embodied energy. Things that are organic and have been around a while, like wood and stone and clay, have generally much lower embodied energy, although certainly concrete's been around since Roman times. And then, if you add krypton to the window or xenon to the window, you're adding much more embodied energy, because again, we have to somehow use industrial processes to make these. So mining, industrial processes, or plastics generally have higher embodied energy. And we see this if we compare polycarbonate to glass. Polycarbonate is like a plexiglass. And so polycarbonate is a plastic. It's got, it's a newer material, and it's oil-based material. And so it's got a higher embodied energy. But again, that's per kilogram. And if you've ever picked up glass, it's shockingly heavy. And if you've ever picked up polycarbonate, it's shockingly light. So if you did it per square foot, it may come out completely different. Then maybe it works out differently. So again, these are things you need to be aware of. Maybe not for the exam, because I don't think NCARB is aware of it, but for your practice for sure. Embodied energy, aluminum versus brick. Well, we just talked about aluminum. Brick is just clay. Brick is really straightforward. So you just take the clay out of the ground, and it's like an old building technique, and you just put it in a mold, and you often fire it, which takes some energy. And brick looks very low compared to aluminum, but even there, you should be getting good at this now. If you didn't pick up on this, shame on you. But aluminum is really light, and brick is very heavy. So this is per kilogram, but if you decide to clad your building in brick, you just have a lot more kilograms. And if you decide to clad your building in aluminum, you have far fewer kilograms. So once you do that on the decision basis of your particular building, I'm not sure that brick is better than aluminum, even though it's very dramatic in the difference. And let the greenwashing begin. Copper, virgin copper versus recycled copper. And we saw this before with steel. So if we have something that's recycled, it generally has a lower embodied energy than if we have something that is mined or extracted. Tempered glass, of course, tempered glass has more of an industrial process applied to it. They heat it up again to make it about 4 or 5 times stronger, more brittle, but stronger. And tempered glass has more embodied energy than glass that is not tempered. Rigid foam insulation, kind of EPS and XPS, styrofoam basically insulation. It's got a whole bunch of oil in it. It's a plastic foam, and so it has a high embodied energy. Cellulose, which is made from recycled paper, maybe 85% recycled paper, maybe 15% something that'll keep the recycled paper from igniting on fire. So, kind of fireproofing material. But that's what cellulose is. They're both insulation. So one is blown in. This one is blown in, and it's just like shredded paper. And this one is extracted with using oil, made with oil. But rigid foam insulation can go on the outside of a building, so it prevents thermal bridging in a way that cellulose insulation, which only really functions in between studs and in between rafters, that's really the only way it functions. And so it could be that the rigid foam insulation over time actually works out better. And certainly if your decision was to, if you wanted to insulate your basement, you wouldn't be doing it with cellulose on the outside of the building. You'd prefer to do rigid foam on the outside of the building. Stainless steel versus regular old mild steel that's recycled. And again, you see if it's heavily processed, there's all kinds of nickel and other alloys and stainless steel, highly processed things. When in doubt, assume that something highly processed has a higher embodied energy than something that has a lower amount of processing. And so plywood with all of its glues has more, about 50% more embodied energy than dimension lumber, which doesn't have all those glues, so therefore is less processed. And some of those glues are epoxies or resins and have petroleum-based products, I suspect. And finally, synthetic rubber. You have a playground and you're trying to decide what the surface is going to be. Well, if your choice is synthetic rubber versus sand, it's pretty big difference. Although again, sand weighs a lot more than synthetic rubber, so you'd have to do that calculation on a per square foot basis. We don't have any questions this week that came from last week, so I thought it was a good opportunity to talk about the Amber Book firm license. The firm license allows you guys to have like unlimited. It's like a buffet, so you get as much access to the Amber Book as you want. Everyone gets a book. These are all the firms. We've only been offering it for about a year, and these are all the firms that are signed up for so far. Plus, we have chapter licenses for AIA chapters. We've set some AIA chapters up with those, and you have the same course that you would have if you were an individual. And then the reason I'm bringing this up is because we have a new policy where if you have another subscription, you can, and you're waiting for that subscription to expire before you go on to Amberbook. Amberbook is free until that other subscription expires. So you don't have to, there's no good reason to wait. And as always, we never take anyone's money who's not thrilled. So if you get a year subscription to a firm license, and if after a year you decide you don't like it, or even after 11 3/4 months, you decide, nah, well, it was fine, but it wasn't worth it, just let us know, no questions asked, we'll give you your money back. We've never had to do that because, well, people generally have a good experience, but if anyone ever wasn't happy, we would definitely give their money back. And then the second new thing is for those of you guys who are on Facebook, we now have a Facebook group as of yesterday. It's, you know, I have a friend, Linus, who said, he said, you know, he was talking about a couple of forums ago. So he was talking about the old, maybe it was the ARE Coach forum. Anyhow, he said it's a shame that there aren't two forums, one for people to kind of vent and get their frustrations out and brag, and a separate one to actually help people. So that's what I'm going to try to do. I'm going to try to create a second one that's only about helping people. So if you have a question about content, you can go to our Amberbook group, 40 Seconds of Competence. You see the theme, right? And you can ask questions. And for the time being, it'll always be me answering it. I can see a time in the future, if it gets really busy, where it may be Ralph also. Ralph is our researcher. But we have lawyers here and researchers here and animators here and architects here. You know who we don't have here is salespeople. So I know I'm doing a little bit of a hard sell here, but generally the reason we're better is because we don't worry about sales. We just worry about making a better course and helping people out, because we actually want people to get licensed. I suspect a lot of people want people to get licensed, but I think that we know how to get you there. All right. All right. This is your assignment for next week. The conference room has one door to the corridor. The office building is sprinklered. What is the maximum size of the conference room? So from a code point of view, the conference room has one door to the corridor. The office building is sprinklered. What is the maximum size of the conference room? Now, you're free to use Google to do some searches. When the email goes out, and email firms at amber-book.com if you want to get on the listserv. When the email goes out, it will have some links to some places. We're gonna treat this like it's a case study, and that you have access to the code. So it has some links to where in the code you can find some of this stuff, but you'll still have to do some searching. But anyhow, the conference room has one door to the corridor. It's sprinklered. What's the maximum size of the conference room?
I have a question, Michael. How you doing? It's Gio.
Hey, Gio.
When we're trying to determine, this is about structure, and maybe you don't know this off the bat, but maybe you do. When we're trying to choose retaining walls, what kind of parameters should we look at for the construction type of that retaining wall, whether we want to make it out of concrete, or we want to make it out of cobblestone, or we want to make it out of wood?
Yeah, I mean,
how do we choose what's right there?
Well, wood is not a great material to have soil touching the back of it. Of course, we can treat it, but generally we prefer not to have soil touching one side of wood at all times, because of course it'll rot. Cobblestone's fine if it's not tall, but as you might imagine, if you have, so here's your wall, and often you'll have something like this for a foundation, and then here's your soil. And so the reason we have a foundation that's so eccentric is because, as you might imagine, there wants to be this kind of overturning moment. And so by using the weight of the soil onto the foundation, this kind of tongue that sticks out from the foundation, we can do a better job of resisting that overturning moment, and we can keep the whole thing from overturning. And then this thing right here is called a key, and it prevents it from sliding. So like if you have a bunch of rain like we had here, the last, like we had here the last 48 hours, we've had flooding. In fact, my kids didn't have school today because it was a flood day. Some of the schools were flooded. On days like today, when all this gets wet, sometimes it wants to slip and the whole thing wants to slide that way. So this key, because it's in the soil also, it creates a little extra friction and ostensibly prevents it from sliding. If it's short, it can of course be masonry like cobblestone, or it could be concrete. But as you know, masonry is not very good in tension. And so if this thing were really tall, and we had masonry, you can imagine that when the overturning moment is up here, because the soil is up here, and we have masonry, you can imagine that it just wants to break at one of the mortar joints. So masonry probably is fine if it's a 4-foot wall or 3-foot wall, but if you're talking about a 10 or 15-foot wall, you usually don't see those with masonry. Oftentimes, in fact, I just ran by it today, and I should have taken a picture. I could pull it up if I had. I already have another picture of it. That's why I didn't. But you'll have these. Help me with the name of these guys if you know it. They're these things that these tiebacks, that's what they're called, that they put into the retaining wall, and they'll put it into grout. So they'll inject grout, which is grout is just like like concrete that's kind of a cementitious material, or cementitious material actually is the right word. And they'll put basically these nails into the grout, giant nails. To answer your question, you asked a bunch of questions, but IIC is a single number rating that is all about impact noise. So all about people walking on the floor above, and how much does that annoy you? Generally, it's most important in multifamily residential, where you can hear the people above. It's not a very good measurement. In other words, if IIC was a person, you wouldn't like IIC very much. It's not good because it's not very accurate at estimating the percentage of people that might be highly annoyed, especially in wood structures, and that's more of what we build these days for multifamily. A good IIC, like a really well done building IIC, might be 65, and if you pay no attention at all, it might be 30. But that's a single number rating. STC, sound transmission class, IIC stands for impact insulation class. STC, which is sound transmission class, and a little plug for my book called Architectural Acoustics Illustrated, which illustrates all these concepts. But STC is sound transmission class. It's also a single number rating, and it's describing how well an assembly does at keeping airborne noise out. So it could be your neighbors above you are yelling, or your neighbors next door are yelling, or have the TV loud, or have a party with a thumping stereo. And SDC, or it's an office and you want speech privacy between your office and the neighboring office. SDC is again a single number rating. A really good SDC again is something like 60, and a pretty crappy SDC where you've really done almost nothing is something like 30. Code minimum for apartments for IIC and SDC are both 50. And importantly, you can have an assembly with a low IIC and a high SDC, and you can have an assembly that's the other way around with a low SDC and a high IIC. So how well an assembly does at keeping footfall out is almost entirely unrelated to how well an assembly does at keeping airborne noise out from the TV or the stereo next door or above. Then there's transmission loss, and transmission loss is like IIC. I'm sorry, transmission loss is like SDC in that it's a measure of how much noise or sound is coming from the airplane outside through the roof to inside, or the bus outside through the window to inside, or the party next door through the electrical receptacle or wall coming inside or coming to your room from the neighboring dorm room, or whatever the case may be. They're both measuring the same thing, except for transmission loss measures it at a per octave band. So it looks at a material or assembly at each octave band, because sometimes, often, materials are good at keeping out sounds at mid and high frequencies, so like speech frequency or a hiss from a plumbing problem, like a pipe hiss, but might be awful at keeping out sound that's a rumble from transportation noise, like the train going near you, or mechanical noise like the mechanical room on the other side of the wall. And then NRC is a single number rating that describes how absorbent materials are, and that's much more about what I sound like right now to you. So I'm in a room that has a very low NRC. It's got a lot of reflective surfaces, and you might have noticed I unplugged the microphone, and that's so now the microphone's not there to help me. Now I'm using the iPad microphone, and so you're much more probably aware that I'm in a room with a low NRC, because there's more. It's not a near field mic. It's not a mic that's intended to just catch what's really nearby. And that's NRC. A high NRC means a room that sounds less like this, and a low NRC is a room that sounds more like the one I'm in, or like a racquetball court. Absorption coefficient is a measurement like NRC that goes from 0 to 1, but like transmission loss, it's measuring it on a per octave band. So it's saying, okay, how much is being absorbed at low tones? How much is being absorbed at high tones? And so we can do some more specific analysis. Now, when you were saying they can combine or they can estimate, yes, they can. That's actually kind of a complicated and surprisingly controversial issue, because, well, there's two things. One is, in the ASHRAE, as you may know, ASHRAE is the American Society of Heating, Refrigeration, and Air Conditioning Engineers, I think. ASHRAE is like the AIA, but for HVAC engineers. And they publish a lot of research, and they have these handbooks. They have like a fundamentals handbook and an applications handbook and so forth that have all kinds of formulas. And the old ASHRAE formulas allowed you, before you had actually before you had selected the air conditioning system, it allowed you to estimate about how loud your system was going to be, and then you could make decisions about whether you needed a silencer, which is like a muffler. So you have the duct, and a silencer goes like this. You know, maybe it's 3, 5, or 10 feet long, and the air moves down, and then there's this kind of fuzzy material in here, and it absorbs. It has a high NRC. It has a high absorption coefficient in there. It has some baffles in between too, and the air comes through and it absorbs some of the sound. So you need to know, you want to be able to calculate, well, do you need a silencer? A muffler? How long is that silencer going to be? Is it going to be too loud in this particular room? And so ASHRAE had a formula in their applications handbook, I think up until maybe 92 or something, that allows you to estimate how loud it's going to be, where you don't know the actual machine, the air handling unit on the other end of that duct, because some of that noise is just going to go right through the duct. Actually, that's probably the single biggest acoustic issue, is noise from the fan, from the air handling unit, going through the duct into a room where you don't want it. And so, we want to know what it's going to be like beforehand. Now, they stopped including it because it was so inaccurate, but I'd rather have an inaccurate. You know what else is inaccurate? Just not measuring and not estimating at all. Because what happens is the mechanical engineers select the machinery. They select the static pressure, which is like the blood pressure of the system. They select the fan diameter. They select the horsepower. All these things affect, and the brand. Some brands are way quieter than others. And, you know, in my experience, train happens to be pretty quiet compared to some of the others, for instance. In general, if the material is more commonly used, it's cheaper. So OSB is cheaper than plywood, and you know that because every time you go past a, you know, a new building, the cladding is OSB. And uh, uh, oh, I don't know, white Portland cement is more expensive. White concrete is more, which is really cool. They have something called white concrete, if you don't know. I poured some concrete countertops for my old house that were out of white concrete.
Mhm.
So white concrete is more expensive than regular concrete. And the reason you know is because regular concrete that you see every day is not white. And so generally, whatever you see more of is going to be less expensive almost always.
Interesting. Yeah.
So if you have a question about that about money, just think of what you've seen the most of in the field, and that's almost always going to be the least expensive thing. But you know,
Well,
go ahead.
it's more the methodology to answer a question. Like, should we off the bat just say what we think it is, or should we also what's in the field because it's more commonly used and it's less expensive?
So you should answer I know this sounds ridiculous, but you should answer the question. And so if the question is focused on what's better, then don't worry about money. If the question's focused on what has a better value, then you need to worry about money, obviously.
Oh,
If the question is about breezes, don't worry about the sun. If it's, you know, if the question's about breezes, I think you can probably ignore the sun. If they don't tell you where it is, then just assume that it doesn't matter if it's a hot climate or a cold climate. So just ignore that altogether, you know. So in general, if they don't, they're gonna, you know, if there's something you should assume, you know,
yeah.
things like gravity, you have to assume. But you don't have to assume that it's in a hurricane area unless they tell you it's in a hurricane area. So
Okay.
so you generally, I mean, these are kind of, and this isn't specific to NCARB, this is just testing 101 kind of in your life. Most questions have a point. Most questions, you can go crazy trying to figure out just what that point is, but my guess is, so the way it works is the NCARB questions, test items are created by volunteers, and there are licensed architects, generally people who have passed the test fairly recently, but not always. And there are people who have found something in the field and they just wish they had already known it. And now a little bit of it is ridiculous, and NCARB will tell them, well, you didn't know it when you got licensed, so why are you expecting new people who get licensed to have known it? But sometimes, you know, it's actually had a lot of fun. I got getting a lot of questions lately about graffiti. I had a lot of fun researching it. It's like, it's really, really interesting. And it's, you know, a lot of graffiti, and, you know, I don't know if NCARB cares about this or if it's in the purview of an architect, but one of the best ways to prevent graffiti is to get rid of it right away, because the person who spends the effort of putting their tag on something wants to believe that it's going to be around for a while. And if you get rid of it the first day, then you will not get graffiti again the next day, because they don't want to go back and forth and do it every night. I find graffiti interesting because people who graffiti tend to never be the kind of people who ever had jobs where they had to do something like clean up graffiti, put it on. But there are coatings, and it's in the flashcards. I don't have them on the top of my head, but there are coatings that you can put down, and there are motion sensors that you can put in with lights, and there are surfaces that are better at resisting graffiti, and actually dark paints. Graffiti doesn't show up as much on dark paint or dark colored surfaces either. That's another one. Thank you. Good night. Get licensed.